Welcome to the Claude Certified Architect Foundations Learning Series. In this series, we use the first principles learning method. We don't just tell you what things are, we teach you why they exist from the ground up. This is Concept 1, Domain 1, and it's where everything begins. Let's go.
Let me ask you a question that sounds simple, but almost everyone gets wrong on the first try. What is the difference between an AI agent and a chatbot? Most people say an agent is more autonomous. Not wrong, but not right either. Because a cron job is autonomous. A scheduled script is autonomous. Neither of them is an agent. So what's actually going on?
Let's start with the world you already know, the standard LLM call. You send a prompt, the model thinks, it sends back text. One round, done. And here is the critical detail. Look at what lives in that output. Text. Just text. If Claude gives you a wrong answer right now, what happens? You read it, you disagree, you correct it. Nothing changed in the world. The mistake lived entirely in the conversation. That is the defining safety property of a standard LLM call. Errors are containable.
Now let's cross to the agentic side. An agentic system starts the same way. A human sets a goal. But then, watch what happens next. Instead of producing text and stopping, the system enters a loop. First, it observes. It reads the output of whatever tool it just ran. Then, it decides. The LLM looks at what it observed and chooses the next action. Not a human, the model. Then, it acts. It doesn't suggest what to do. It does it. And then, it loops back. Observes the new result, decides again, acts again. This observe, decide, act cycle, running autonomously, step after step, with the LLM as the decision maker at every iteration, that is what agentic actually means.
When you hand that loop to an AI, you introduce 3 risk properties that simply do not exist in a chat window. The first is irreversibility. In a chat, mistakes live in text. In an agentic system, mistakes live in the world. The agent doesn't say, "I'll move these records." It moves them. Deleted records, sent emails, executed trades. And moving them back, if that's even possible, is a completely different problem.
The second risk property is cascading failure. Each action in the loop becomes the input to the next decision. So if step 3 goes wrong, the agent doesn't know it went wrong. It takes step 4 based on the broken output of step 3, then step 5, then step 6. By the time anyone notices, you're not debugging one mistake. You're unraveling a chain of them. One bad observation poisons every decision downstream. That's cascading.
And the third risk property is opacity. The agent may not surface its reasoning at each step. It may execute dozens of tool calls before returning any visible result. The reasoning lives inside the loop, invisible to you. You might not know where it went wrong until the damage is already done. 3 properties: irreversible, cascading, opaque. Memorize those. They will come up on your exam and in every product design review you run. So what does Anthropic recommend as the design response to these 3 risk properties? The minimal footprint principle. 3 parts. First, least permissions. Request only the permissions the task actually needs. No more. This limits irreversibility at the source. Second, reversible by default. Prefer actions that can be undone over those that can't whenever there is a choice. This contains the blast radius of any one mistake. Third, pause when uncertain. When confidence is low, surface the decision to a human before proceeding. This is what catches cascading failures before they cascade. Slower, final cadence. Deliver as a mantra. Least permissions. Reversible by default. Pause when unsure.
Let me show you what this looks like in the real world.
In a RAG-based SAS to Python code conversion workflow, a checkpoint was placed between spec generation and code generation. Why exactly there? 3 reasons converge at that point. First, the analyst has irreplaceable domain knowledge. Only they can confirm whether the spec actually captures the business logic, not just what the code literally does, but what it was supposed to do. Second, catching an error at the spec stage costs 1 review cycle. The same error caught after code generation costs sprint velocity. Third, crossing into code generation is crossing into semi-reversible territory. The checkpoint belongs at the reversibility boundary. Checkpoint there. Not everywhere. There. Let's close with the clean definition. A system is agentic when the LLM is placed inside a control loop, not just at the end of one. It observes the real world, decides what to do next, and acts on that decision, repeatedly, without requiring a human prompt at each step. That capability is genuinely extraordinary, and it demands equally careful design. Because the same property that makes agents powerful is the property that makes their mistakes expensive.
In Concept 2, we look at human-in-the-loop design and dig into what makes a checkpoint placement genuinely effective versus what makes it just theater. We'll cover the HITL placement logic, the reversibility spectrum, and the grounding concept. It builds directly on what you just learned. Don't skip it.
If this helped, please like the video. It helps the series reach more people preparing for CCA-F. Subscribe to BornToSkill on YouTube. The handle is Born_to_skill. You can also find us on X and Instagram at the same handle, Born_to_skill. See you in Concept 2.